Okay, so in your work folder, I'm going to do this side that says number one, extended response scatter plot, federal spending. The one that looks like this starts with 1991. Okay, I'm going to do that one with you. And then you're going to do a similar one on the back. Okay, the one that starts with 2001. You're going to do that one on your own. Okay, so the first thing to mention is that we want to make our x-axis have the same interval all throughout, not have a big jump on the x-axis and start with 1. Okay, so when this comes into play when you have years. Okay, so for example, you wouldn't want to start the x-axis at 1991 because that'd be 1,991. It would jump from 0 to 1,991, and then you'd be counting by ones after that. Okay, so we're gonna say 1991 is year 1, 1996 is 6, 2001 then would be 11, 2006 16, 17, 18, 19, and 2010 would be 20. Okay. All right. So I'm going to go ahead and label here the x and the y-axis. So I got year for the x. Okay, and then dollars in billions. Okay, dollars in billions. Okay, for the y. Okay, so let's go ahead and number our x-axis. Okay, so it looks like I'm going from 1 to 20. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm not going to have enough. Okay, so I'm going to count by twos. Okay, so I got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. Okay. All right, and then the y's, I am going from, looks like my lowest y is a 4, and my biggest one is a 13. So let's see how many I have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you know what? Since it only goes up to 13, I'm going to go ahead and count by ones. Okay, but I'm going to start at 4. I'm going to do a crooked line here to meaning that I'm going to jump. Okay, and I'm going to start at 4 right here. Okay, so a crooked line right there and jumps to 4. Okay, so let's go ahead and after that I'm going to number by ones. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then 14. Okay. All right, so let's go ahead and plot these points. 1 is 4.5, so 1 is 4.5 right there. 6, so here's our x, and here's our y. Okay, 6 is 6.6, so 6 is 6.6. 11 is 11.6. Year 11 is 11.6. Year 16 is 12.6. Year 17 is 12.7. Year 18 is 13.1. Year 19 is 12.9. Okay, and year 20 is 13.4. So way up there. Okay. All right, so draw a line of best fit for the scatter plot. All right, so if you have a ruler or some type of straight edge, I guess I'll find one really quickly here. Just draw your line of best fit. I'm just going to use this folder. So my line of best fits will go through the points. Okay, so about right there. Okay, so there's my line of best fit. All right, so let x represent the number of years and y represent the billions in dollars, right? A slope-intercept form equation, that's y equals mx plus b, slope-intercept form. The equation for the line of best fit. All right, so I need to find the slope. Let's find 2 points here. I don't really see 2 points. I will estimate it though. Let's go with that point right there is, I'm going to say, is close enough. And what's another close point? You know, it looks like it's pretty much just 1/1. Okay, so I'm going to go with this point right here. I'm going to say there's my slope. Okay, so my rise is 1. And my run, look at my x, they're counting by 2's. Okay, so that's 2. Okay, so my slope, okay, is 1/2. Okay, so just 1/2. I can change that to 0.5, okay, or 0.5. And the units are always y/x, billions of dollars per year. Okay, so $500 million per year. Okay, so 0.5. All right, and then my y-intercept, let's say that's like 4.2. Okay, so the b is about, I'm going to do 4.2. Okay, so b is about 4.2. All right, so I'm going to put it into y equals mx plus b. Oh, sorry, I guess I didn't have the camera all the way down. All right, so my slope is 1/2, and my y-intercept is 4.2. Okay, so let's go ahead and write our equation. Y equals, I can use either one. I'm just going to go ahead and use the 0.5. 0.5x plus 4.2. Okay, so there's my equation for the line of best fits. All right, predict the amount that will be spent on space and other technologies in 2020. Well, this is a little bit outdated. We've already passed 2020. But from this data, right, so the year 2020, okay, can't write 2020. So the year 2020, if the year 2010 was year 20, the year 2020 would be year 30. Okay, so our x would be 30. All right, so x equals 30 in this case. Okay, so in the year 2020, our x would be 30 from our table. Okay, so I'm going to use this equation. Y equals 0.5x plus 4.2. And my x is 30 for year 2020. So y equals 0.5 times 30 plus 4.2. Okay, and from there you can just put it into your Desmos calculator. I'm just going to use this handheld one here. Okay, so 0.5 times 30 plus 4.2, and it looks like it's about 19.2 billion. Okay, remember the unit's $1 billion. Okay, so your y equals 19.2 billion dollars. Okay, all right, so that is the front, and then on the back, similar type of problem. I just changed the numbers up just a little bit. Okay, for you to do one item.